Hello everyone, welcome to my channel Chinga Online Math, and in this video I want us to look at two ADMA questions. Question 1 is on calculus differentiation. It reads, given that y is equal to square root 4 plus 3x, find dy dx of this function. So we want to get the derivative of the given function. Then question 2, prove the identity cot squared theta sec squared theta equivalent to 1 plus cot squared theta. So we want to prove is the left hand side equivalent to the right hand side. So we'll come and work it out later on. Let's start with question 1. So for our solution, starting with question 1. So for question 1, we are going to start by first of all writing this function in another form, which is this form, y equal to, open bracket, 4 plus 3x, close bracket, power 1 over 2. So y equal to square root of 4 plus 3x is the same as writing it this way, y equal to, in brackets, 4 plus 3x, then power 1 over 2. So since this 2 means root, so since it's 2, so square root, then this one is the exponent or the index. Okay, so after writing the function in this form, y equal to, open bracket, 4 plus 3x in brackets to the power 1 over 2, we can now find the derivative of the function. This here is a function of a function. In short, it's a composite function. So this can also be written as y equal to, so we're going to let 4 plus 3 equal to u. So this means that we've got y equal to u, which has power 1 over 2. Okay, so we let u equal to 4 plus 3x. So what we have here is a composite function. So meaning now we are going to look for two things here. We're going to look for the derivative of this one, dy du, and we're going to look for the derivative of this one here, du dx. So since here the relationship is y and u, and here the relationship is u and x. So this is just basically chain rule. Okay, so we're going to do the following. For this one, we're going to say dy du is equal to, so if you want to find dy du of this function, this just simply means that we are going to multiply the half by the coefficient here, which is 1, then subtract the half minus 1. So this is just 1 over 2, keeping u, and then this power, half minus 1. Now, half minus 1 will give us negative 1. So what we're looking at for dy du is the following. So dy du is going to give us 1 over 2 u to the power negative 1 over 2. Since half minus 1 is just simply negative half. And this here, we are going to multiply it with what we're going to get here. So let us get the derivative of this one. So what is du dx? So du dx is going to give us the following. The derivative of a constant is 0. Then the derivative of this one, 3x. So x here has got power 1. So 1 times 3 will give us 3. And then the power of x here minus 1. So 1 minus 1, that is 0. So x to the power 0 is simply 1. 1 times 3 will just basically give us a 3 there. And then we are now going to combine these two. So to get dy dx, we are saying this is the multiplication of dy du times du dx. So this is going to be written like this. So now, on dy du, we got this. On du dx, we got 3. So dy dx is equal to 1 over 2 u. Now, this u to the power negative 1, okay, negative 1 over 2 is the same as just writing it like this. It's the same as actually just writing like this. 1 over 2 u. So u will be below. Okay, u will go down because of the negative. Okay, to get rid of the negative, you will drop u. So it will multiply with 2, and then it is going to have power half. So here 1 over 2. So we have 1 on top here over 2u to the power 1 over 2. So u has power half. Then multiply by on du dx. Du dx, remember here we got du dx as 3 from what is inside here. So the derivative of what is inside here, 4 plus 3x, gives us 3. So we're going to have 3. Now remember, since we let u equal to 4 plus 3x, so it is now time we get back our function. So on u, we are going to put 4 plus 3x on the next stage. So dy dx is equal to 1 over, so 2, open bracket, so this here will be 4 plus 3x, 4 plus 3x, then power half, then all these times 3. Now times 3, on the next stage we're going to multiply with the 1, so this will just give us 3. So dy dx is equal to 1 times 3, this is just 3, then over 2. Half is the same as square root. Remember we said 1 is the exponent, 2 is the root. So this gives us the following. Square root of 4 plus 3x. So this here is the derivative of the function y equal to square root of 4 plus 3x. So all we simply do is, first of all, let u, okay, u equal to 4 plus 3x, and we are going to have y equal to u to the power half because of the square root, and then we differentiate the two functions that we get. So we differentiate y with respect to u and also differentiate u with respect to x, and then we multiply what we get there to find dy dx. Okay, going to the second question, which is on identities. We want to prove the identity cot squared theta sec squared theta. Is it equivalent to 1 plus cot squared theta? So here is the solution. Now for this part, I want us first of all to remind ourselves of some identities. Okay, this one here, the first one, cot. What does cot mean? Cot squared theta is the same as 1 over tan squared theta. Okay, so let's take note of this one. And this one, 1 over tan. Remember, tan is the same as tan squared theta is the same as sine squared theta over cos squared theta. So we need to know this. So meaning that cot, if this is 1 over tan, and we know that tan is sine squared theta over cot squared theta, then it means 1 over this. What is 1 over this? So this is just the inverse. We will reciprocate. Okay, so this will mean that cot squared theta is equal to cos squared theta over sine squared theta. Okay, so this is the cot. So on cot, we are going to put this. Then the other thing that we need to know is sec squared. Sec squared theta. Sec squared theta is the same as 1 over cos squared theta. Okay, so this is the same as this one. Then the identity that I want us to remind ourselves of is cosec. Okay, we need cosec. So cosec squared theta is the same as 1 plus cot squared theta. So we need this at some point. Okay, so that's what we have. So now let's prove the identity. Proving the identity, I'll just start with what I was just talking about. So for cot, that is question 2. So we're saying we're going to take the left hand side. So taking the left hand side, proving the right side, taking the left hand side, this is going to give us the following. So for cot squared, we said this is the same as cos squared theta over sine squared theta. So cot squared theta is the same as cos squared theta over sine squared theta. So we proved it earlier on. Then this one, sec squared theta, this one is the same as 1 over cos squared theta. So then, what can we do here? All we do is just simplify this. Okay, we can simplify this into this. So this here gives 1, even this one also gives 1. And what we're going to remain with is 1 over sine squared theta. Okay, 1 over sine squared theta. And 1 over sine squared theta is the same as cosec. This here is the same as cosec squared theta. Okay, and then cosec is the same as this one. So we know that cosec squared theta is the same as 1 plus cot squared theta. So hence we've proved it. Okay, it's already shown. So what did we start with? We know that cot squared theta is the same as 1 over tan. Okay, and 1 over tan is sine squared theta over cos. So meaning that cot squared theta is the inverse, okay, of tan. So which gives this. So we start with cos squared theta, then write sine squared theta, then times sec squared theta is the same as 1 over cos squared theta. And these two can simplify. So cos squared theta into cos squared theta, we're getting 1. 1 times 1, here we're getting 1. Then sine squared theta times 1, we're getting this. And we know that this is the same as this. 1 over sine squared theta is the same as cosec. Okay, cosec squared theta. And earlier on, we also talked about cosec squared theta. It's just the same as 1 plus cot squared theta. So, hence proved. Hence proved. Hence proved. So this here is just the simple solution to this question here. Okay, so thank you so much for watching this video. More questions in additional maths are coming, so just stay tuned. Thank you so much.